Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. And by the way, I want to thank one of my subscribers for commenting that she couldn't find bonus weather video number 1 for last week, and it got uploaded to YouTube, but for some reason it never got published to Patreon. And so I appreciate them letting me know that, and so bonus weather video number 1 showed up after 2 and 3. So anyway, well, today we're going to talk about something that we've talked about before, but we're going to maybe look at it in a slightly different way, and hopefully it's not going to be too confusing. So let's go on ahead here, and I'll put myself down here in the corner so you can see the graphics. So this is the sunrise and the sunset through the year, and I didn't get myself down there. Let's see here. There we go. So, and it's not even important. I didn't even label the y-axis in terms of time, okay, because it's just looking at it in a relative sense. And of course, the interesting thing about this is that the sunrise and the sunset do not converge symmetrically on the shortest day of the year, nor do they diverge symmetrically on the longest day of the year, okay? So if we break this down here into 4 different categories, the latest sunrise actually occurs about January 5th or 6th, okay? And the reason that the days are getting longer, despite the fact that the sunrise is getting later, is that the sunset is getting later at a quicker rate, okay? So the days are lengthening after December 21st. The earliest sunrise occurs about a week before the summer solstice, about June 14th, on or about that time. And then the latest sunset occurs about a week after the summer solstice, okay? And the earliest sunset occurs about 2 weeks before the winter solstice. And I brought this up in the daily weather update that the sun's going down about 5:05 now. It's only going to get 4 minutes earlier than it is right now. That'll be about the 5th of December. And then it'll start getting later, even though the days are still going to be getting shorter until December 21st. So all of this due to the fact that the Earth's orbit around the sun is not circular, it's elliptical. We're actually closer to the sun. This blows a lot of people away in January than we are in July, okay? So the distance to the sun has very little to do with us getting hot and cold. It's the angle at which the sun's radiation hits us, okay? The sun is almost 80 degrees above the horizon in June, which is not quite directly overhead, but almost. And this time of year, it's barely above 30 degrees above the horizon. In fact, I don't know if you've noticed or not, but when you're driving along, even in the middle of the day, the sun is low enough in the sky that it can still blind you if you're driving right at it, okay? So that's more and more of a problem in the wintertime, and then things will start to improve in that regard as we head into the spring and summer. Okay. Now, this is the part that I'm worried about it being confusing. This is the rate of change of the sunrise and the sunset, and that red dotted line is where the change is 0, okay? So let's take a look at the sunset first for the early part of the year, and it is getting later and later and later until you reach this point here, about a week after the summer solstice, and then it starts to get earlier and earlier, okay? And then, if we take a look at the sunrise, it continues to get later. You see how it's just slightly above that dotted red line in early January? But then it starts getting earlier and earlier, and the rate at which it's getting earlier occurs in March, and then it still keeps getting earlier, but just at a slower pace. And then finally, about a week before the summer solstice, then it starts getting later again, okay? So there's the sunrise getting later, and the sunset is getting earlier once we get past about the, maybe the middle of June, and then it gets earlier at the quickest rate in September, okay? And then it still is getting earlier, but the rate at which it's getting earlier is slowing down. Now, one thing I found fascinating about this, because I had never actually graphed this out before, is that do you notice how, with regard to the sunrise and the sunset getting earlier, there is a definitive maximum rate of change, okay, right in here. But with regard to the sunrise and the sunset getting later, it's not quite as definitive, okay? In fact, if you look real closely, there's a little bit of a dip right there, okay? And it's sort of flat overall. And the same thing here. There's that little dip right there. And then once we finally reach this point, then the rate of change really begins to change, okay? But again, this is probably in all likelihood due to the orbital characteristics of the Earth going around the sun, and also the fact that the Earth is tilted on an axis about 23.45 degrees. All those things come into play in terms of determining the sunrise and sunset and when they're earliest and when they're latest and all that sort of stuff. So anyways, I thought you might find that interesting, and it was interesting when I was doing this in Excel. I found it difficult to plot actual times, and so what I had to do, like for instance, if I was looking at the time of like 5:45, I had to convert that to a decimal, okay? So there's 60 minutes in an hour, 45 is 0.75, so I had to make it 5.75. Once I did that, then I was able to plot it with no problem, okay? And then with regard to the changes, if I actually took the absolute change every day, there'd be a whole bunch of noise. And so what I did was I took a 9-day running average so that I could smooth it out and get the kind of plot that you see there. Okay. All right. You all have a wonderful Monday evening, and we will talk to you again about this time tomorrow. Next bonus video Wednesday, next daily update tomorrow. See you later, everybody.